earn daily income for your livelihood and losing it due to something as simple as rain or a sudden restriction. We are the Quants from SRM Institute of Science and Technology, and we present GigShield AI, a solution to protect gig workers from income loss. Gig workers face unpredictable income on a daily basis. Disruptions like weather, pollution, traffic, or city shutdowns can reduce their earnings by 20 to 30%. At the same time, they lack basic protections like CQIP or guaranteed income. In India, over 15 million gig workers depend on daily earnings, making this a critical issue. The gig economy is growing rapidly, with millions relying on delivery, ride sharing, and freelancing work. These workers are essential to urban life, yet the financial stability has not kept pace with their growth. This makes the problem more serious. Gig workers contribute significantly to the economy, but they remain financially vulnerable with no income security or support during disruptions. Existing solutions like Aquotito and Mix Global mainly focus on health or vehicle insurances and not income protection. Their claim processes are slow and manual and not suited for gig workers. This highlights a clear gap, the need for a real-time automated income protection, which a solution aims to provide.
Let me quickly walk you through our system architecture. We designed this as a microservice based backend, so each core function like user management, policy handling, claims, and payment works independently and scales easily. At the core, we have real-time event monitoring. The system continuously pulls data from external APIs like weather, AQI, traffic, and even government alerts to detect the disruption as they happen. On top of that, we have an AI-powered decision engine. This handles risk prediction, fraud detection, and income loss estimation. So payout are accurate and fair. And finally, once a disruption is verified, the system automatically triggers the payment. So the workers gets compensated instantly without any manual process. Now I will explain how system works from a user perspective. First, the worker subscribes to a weekly protection plan through our application. Then the system continuously monitor external conditions like weather, pollutions. If a disruption happens, from example heavy rains or high AQI, the system detects it based on the predefined threshold and identifies affected workers in that area. After that, the claim is automatically generated. The worker doesn't need to apply or fill any form. Then our AI models verify the event, calculate the income loss, and check for any fraud event has been occurred or not. And once everything is validated, the payment is transferred instantly. So overall, it's a completely zero touch process, no paperwork, no delay. Coming to our tech stack, on the front end, we are using Next.js with the app router, React with TypeScript, and Tailwind CSS for fast and clean UI development. We also use SatCN UI for better component. For the backend, we use a TypeScript-based setup with Next.js API routes and Node.js, which keeps the system type safe and easy to manage. The AI layer is built in Python using Scikit-learn, Pandas, and NumPy for building the prediction models. For storage, we use Supabase using, uh, sorry, we use PostgreSQL using Supabase for structured data and Redis for caching. We will deploy it on our one AWS and we'll use Docker for containerization. And for external data, we integrate APIs like OpenWeather, AQI, and Google Maps.
Myself, Rashid, I'm going to talk you through the technical stack that we are using in this application for the working profile, admin dashboard, and our APIs. So the application that we are using here is the Next.js, and for backend we are using the Node. I'll explain you why we are using Next.js and Node now. So Next.js allows us to keep our front end and backend within a single repository. By layering within a single repositories, all the server components will get incredible out of the box performance because we are entering UI directly from the servers. This reduces the amount of JavaScript that we need to write and reshape it to the browsers and make data fetch much simpler. So for this, we are going to use TypeScript, which is an end-to-end type safety means the data structure we define in our databases are strictly enforced all the way to our backend API down to the front-end UI components. And talking about the uh, talking about the backend, we used PostgreSQL, which is PostgreSQL is a generates is a bridge for the database. It's a type safe database client. Raw SQL, instead of writing raw SQL data, we make it much easier. Like where Prisma allows us to interact with our database using TypeScript models. It changes it changes the columns into databases. TypeScript will immediately flag any front-end or back-end code that needs to be uploaded. So in this, we are using two main things. They are breakscript, script.js. Script.js is that hashing all passwords secretly to allow sensitive users credentials are mathematically protected. Now I'll show you where we are using this. Yeah. So basically, you see here, this is the superbase in which our as per PostgreSQL that is being used, and these are the users. These are the current users that are being enrolled in the project right now, and these are the notifications columns and policies for the riders whoever is riding. And let's go through the project now. Let me run the project. This is the starting of the project. So basically, you have two types of the roles: the workers and admins. Admins are us who gives them policies and all the information regarding the uh, notifications or the payments that we give them. And when we log in, we have to first register. For now, we have given normal registration, like if you give normal like uh, harsha1@gmail.com. That's the name, sorry, harsha1, and the email is this. Password is and see, got successfully created. So when we go back to our database and refresh it, see the harsha1@gmail.com is currently got fetched from the front end and it is shown in the database. And when we try to log in with that same ID, so this is the main page of the workers where you can see in the side policies mentioned for them, claims, payments in a sense whenever they are in like not able to get their money, where they can have their premium status to buy, and they can have the alerts regarding the weather conditions or the other problems. And this is the user profile of the worker. And here we are going to use our AI models in which we are going to predict the current weekly frame, like how much they have to pay, and weather condition and instant payment availability for like if there is any claims or something, they can easily fetch it from here. And they have event integrated like a location API, weather API and all will be integrating, which makes them easier to fetch the data. Now, if you go to admin side, let's go to admin side, we'll register. So this email is already new, so we'll be not using multiple emails. So this is the admin admin portal where you can see historical ratio, like in what is the ratio of like amount that has been decreased or increased in the particular month per capita, and they can see the loss coverage ratio, and they can see all the detected frauds in this. And they can also see the information of the workers, whoever is there in the particular field. It's not single field; we can also have multiple fields. Then we have claims and frauds, and there's also a user profile for uh, admin. Let's go to the GitHub. So we see we have posted, and the key features are the worker portal admin dashboard and secure architecture and real-time notifications. So it is an automated real-time alert update working efficiency where their claims are preceded and actions are needed. And this is our architecture and system design that I have explained right now, using which our models are been having the will be having the will be deployed using the REST API, and we'll be using the endpoints to get the information from them and use it in our website so that the alerts are given to the workers. And this is our data models. As I told, we are going to use data models. So there are four major data models that we are using. They are the risk and underwriting agents. This is a policy insurance type in which they find risks and give them alerts. And the next one is a live parametric monitoring in which they are monitoring weather. Claim and settlements, it is detection of fraud investigation agents. And fourth one is visual evidence check, whether the payment transaction is done or any claims is rejected or accepted. We're gonna check through this. So yeah, this is about the project.
Goal is to reduce the manual work and speed up the claim processing and make insurance smarter using AI. The AI decision engine acts as a brain and it combines the outputs of all the models and automates the final decision. The risk intelligence model, in this we have used the push model where we have taken inputs like weather, traffic, distance, ratings, and past data of the gig workers, and we have classified them and the output as risk or not. The AI decision engine, it combines of outputs of all the models and applied rules. For example, if the risk is high, then it will lead to high premium. If the fraud score is high, then it will lead to claim rejection. In the impact income estimator, it is a regression model that estimates the income loss of activities and data, and it demands of the patterns and ensures the accurate compensation. The multimodal AI system, it ensures the upload of the data of the flood, accidents, and all those things by gig workers is true or not. If the claim is true, then it will lead to claim rejection. If it comes in the false category, then it will lead to the rejection of the claim.
Now, let's talk about how this works as a business. Our primary revenue comes from a weekly subscription model, typically from 20 to 100 rupees per user. We also plan to integrate the platforms like Swiggy, Zomato using a B2B to C model, which allows us to scale quickly. To give a simple example, if we have a 1K user paying 50 rupees per week, that generates 50K rupees weekly revenue. So the model is simple, scalable, and directly aligned with how gig workers earn. This solution is very feasible in today's market. The gig economy is growing rapidly, and more workers are depending on it as their primary source of income. And at the same time, we have shown the MPs in the parliament who have raised issues on it, and government are also focusing on the workers protection, which supports solutions like ours. And another key factor is climate risks. Events like heat wave, floods, so pollutions are increasing, so which directly affects the gig workers. So parametric insurance is already being used for weather income protection in other sectors. So uh, combining with combining this all this say, parametric all these parameters with AI makes our solution scalable and practical today. Finally, what makes our solution stand out in the innovation and impact? Our innovation side, we have zero-touch claims, AI-based pricing, and real-time event triggers. On the impact side, this provides financial security to gig workers, help them recover faster after disruption, and can scale across the entire country. And at the end of the day, our idea is very simple. We can, if we can measure the risks, we can ensure income. Thank you so much.